software. So as we've seen,
don't forget to share your slides. Don't forget to share. Do you have slides?
Yes. And I've already went through, and I'm not sharing. Thanks. Just share that. Yeah. So can everyone see my slide? It says computer system.
Yes, we can.
Yes, I can see it.
Okay. So basically, a computer system consists of two components, which is hardware and software. And we said hardware are all physical components that we get inside the PC, all the things that we can touch, the processor, the RAM, the printer, speaker, and all those things, they make the hardware part of the computer. So today we'll be getting into the software part. So what is a software? A software is a set of instructions that tells the computer hardware what to do. What to do is known as a computer program. This program or collection of such program is known as a computer software. So basically, a computer software is a collection of instructions that perform a specific task. So going deeper, we're saying software guides.
Obakeng, I think we have a question. Sandile, can you hear Obakeng on your end?
Yeah, I wanted to ask, is this class recorded?
Yes, we're recording on my end, yeah.
Yeah, I'm experiencing a problem here.
No problem. I'm gonna share it with you. Which group are you under?
System development. System support.
Rito.
Yeah, yes.
Okay.
Okay, sure.
Go ahead, Obakeng.
Okay, thanks. So going deeper, software guides and tells computer hardware how to accomplish a task. Computer software can be categorized into two broad categories as system software and application software. So now we've already had a point that software guides and tells the computer hardware what to do. So basically, without our software, the hardware is nothing. For us to function, all the hardware to function, we need software. So computer software can be categorized into two broad categories as system software and application software. So we can see here we have system software, which are your operating system, device drivers, language translators, utility software. And on the application side, we have your word processors, spreadsheet, image editors, database management systems. So on the operating system, you find different operating systems like Windows. We have Windows 8, Windows 10, and we have the iOS for Apple. And we have also the Linux, which also works with Ubuntu. Those are the different types of operating system. We'll dive into more deeper. So on the application, we have your word processor, which you know, the one we use to maneuver data, spreadsheet, which are your Excel, image editors, those like your Photoshops you use to make movies and stuff like that. Database management are mostly used when programmers are building a system. Those are like MySQL, and yeah, we'll also dive into that deeper. And web browsers. So web browsers, we know them as Firefox, Chrome, and all those stuff. So system software are a set of programs which are used to control computer activity and computer hardware system and computer hardware. System software also provides platform for application softwares. Application softwares are those programs which are designed to perform specific tasks, and application software recovers system softwares for their existence. So we know that we have system softwares and application softwares. So on this diagram here, you can see we have the hardware, system software, application, and you as the user. So the application softwares, which are your Word, Photoshop, and all that stuff, for you to use them, you're gonna need the system software. So the system software is what your operating system, and the operating system works in hand with what the hardware. So basically, we are saying that for your computer to function, we're gonna get the computer case all together. Then also we're gonna need the system software. So what does that mean? Once you have all your hardware components all together, you install a software into that computer for it to function. So mostly in nowadays business, we usually familiar with Windows 10, Windows 8, and all that stuff. So that is the system software. Then application software are specific, like we read, they are specific to the task. We have application software that are used in, let me see, to make an example, that are used in call centers. So those system software, they track people. Maybe let's say you are working at a call center that does debt collecting. Those systems will be used to track people who owe and people who are already paid the debt. And also on that systems that do calculations on the forex market. So those systems are basically robots whereby they look on the market for opportunities and they tell the user which opportunities to take. Yes, so going down, we also have the firmware BIOS. So firmware BIOS performs the following three important useful functions of PC. It boots the computer, it validates the PC's configuration, it provides an interaction between hardware of the PC and its software. So that is the BIOS. So BIOS stands for Basic Input Output System. So the BIOS is the one that always starts when you turn on the PC. It's the one that takes place. Like they say, it boots the computer, it validates the PC configuration. So validating the PC configuration, that's where when you start your PC, it will check your hardware to see if it's functioning properly, if there are any errors of your hardware. And also it provides an interaction between hardware of the PC and its software. So that's where we get terms like drivers. So there's also a software that is called a driver. We'll get into that later. The driver is a software that works hand in hand with the PC softwares. So system software. These are set of computer programs which are required for controlling and managing the hardware resources, as we've read earlier. System software is required for the proper functioning of the computer. System software usually interact with hardware and provides platform for running application softwares. Basically, they are just repeating what I just said then. An operating system. An operating system is a collection of computer programs that guides the computer hardware to do different activities under a variety of conditions. System software provide common core services required for other software to run. It also performs resource management and provides interface between the user and the machine. The basic function of an operating system. So we've also read that the operating system, it provides interface between the user and the machine. So that's where it comes. Before we had this Windows, there was once operating system called DOS. It was Microsoft, I believe it's Microsoft DOS. So this operating system back in the days, you would only use command line to interact with the operating system. So as you can see in this image, it was always black. When you needed to do everything, you'll have to type in words. Like as you can see here, it's dir for directory and everything. So we also find it in the latest computers and operating system. If you type cmd, command prompt there. So basically, it was more of something like this, the CMD. Those were the olden operating system. So now we have the new operating system whereby they give interface with an interface between the user and the machine. So whenever you maneuver your machine, those graphic user interface that you see where you are able to click the images, back then we didn't have those kind of operating systems. So those are the benefits of the operating system. And here we know it process management, memory management, file management, device management, security management, and creating user interface. Going deep into the operating system, it can be defined as a system software which acts as an interface between user and the system and manages the resources in efficient ways. The primary goal of an operating system is thus to make the computer system easy to use. So like we said, it gives us the graphic user interface instead of us typing in that black and white screen like the Microsoft DOS back in the days. Okay, before I go further to device drivers, any questions on the operating system? Any questions? Okay, I guess there is no question. I'll move on. Okay, device drivers. Device drivers are a set of computer program that controls the operation and functionality of different devices. Computer system is generally associated with different devices such as keyboard, mouse, monitor, and printer. Functioning of these devices is controlled by device drivers. Each device in the computer system has a device driver associated with it for proper functioning. So now we know that for the computer to function, we need an operating system. So among that operating system, there's also softwares that are called device drivers, which we know that they make our hardware like keyboard, mouse, monitor, and printer to have functionality. So back in the days when we used, I believe it stopped with Windows 8, but before Windows 8, during the Windows 7 on XP, after installing an operating system, you had to install device drivers for like sound drivers for your speaker to work, because after installing operating system, the speaker could not work. Then you had to download the device drivers to install them so the speaker can work. Also for the keyboard, also for the printer. But now with Windows 8 and all the evolution, the device drivers are embedded in the software. So when you install an operating system, the device drivers are already there. Language translators. Since computer understand language consisting of zeros and ones, language translators are computer programs which translate program written in programming language to machine language and consist of sequence of zeros and ones. So guys, we've mainly seen mostly in movies of hacking. Every time when someone hacks, we see these green screens and all that stuff. Yeah, so basically it's like this, okay? So bits and the machine language that a computer understands, it's written in ones and zeros. So that's the, oh, sorry, can I just excuse myself for that? So those are the things that computer understand. Those are the languages the computer understands. It understands the ones and zeros. So for the, okay, let me just accept people in the lobby. So for the machine to understand the language that we talk, which is English, it uses language translators, which is a set of ones and zero. Then it translates them back to what we know as our language. So that's basically the language translator. Utility software. Like hardware, software in computer also needs maintenance. Utility software are programs that are used to maintain, support, enhance, and secure existing programs. Example of utility softwares include backup softwares, antivirus, data recovery softwares, disk management, etc. So utility softwares, guys, are also embedded in the operating systems, as we've seen that they say. It also helps us to do stuff like maintenance and support, security, and all that stuff. So utilities are embedded in the operating systems. Like there's one that I know that is it's called. So once your computer crashes, its restore point is. Let me just show you there. It's called restore. Yeah. So there's also a restore point, which is a utility software. So a restore point, it allows you to set a restore point of your PC to a functioning state. So right now, as you can see, my PC is functioning, right? I'm going to create a system restore. So in case, whenever from now on, if my PC crashes, I can restore it back to the time where it used to function correctly. So yeah, before I continue again, any questions, guys? Any questions? No questions. Moving on. Application softwares. These are a set of computer programs which are designed to perform specific tasks. So like I explained earlier, application softwares are the application softwares that perform specific tasks depending on the work base that you're doing. So for people in the media, I know they use Photoshop to edit pictures and for also making movies. So specific to your industry, it will depend. So like also for IT people, they have applications like to build program for what they call them the IDE. So those are the application they use to build or develop programs. Like I have one here. Let me just see. Yeah, IntelliJ, which is one of them, Eclipse, which is also one of them for IT people. These are basically application softwares. And WhatsApp is also an application software, guys. That's also a typical example. So yeah, most commonly used application softwares are your word processors from Microsoft Word. Sorry for that. From Microsoft Word, which most of us are familiar with, spreadsheet, which is Excel, and mostly used for dealing with numbers, I can say, yeah. Then image editors are your applications. Database management are the stuff like Oracle, MySQL, also used by IT people to store data. Web browsers, those are your Microsoft Edge, Torch, Google Chrome, Firefox, and also firmware. So firmware software that has been written onto read-only memory. So this firmware, it's such software that comes already embedded in the memory chip. So if you can check so this is the kind of chip we're talking about, guys. It comes with it already has the software embedded in it. Okay. So there's also the PROM, which is programmable read-only memory. Then the EPROM is erasable programmable read-only memory. Hardware used for input and output. Okay, so now we're moving into output and input. A computer cannot sense the outside world to communicate with outside world. It needs some devices, which are known as peripherals. An input peripheral device accepts input from the user and feeds into the computer, e.g. keyboard, light pen, mouse, joystick, and all that stuff. So what basically they're saying here, they're saying now we have the hardware, which is the case, the keyboard, the screen, and everything. We have the software of the computer, it's functioning. So for the computer to interact with us, for us to see the computer as useful, we have to have some set of peripheral devices for us to insert data into the computer, so it does the calculation or whatever it does, then gives us the output. So basically, those are the peripheral devices. So input peripheral devices are your devices that let you input data into the computer, like a keyboard, you type data into the machine. Light pen that lets you write whatever you write on that pen, it already types it in the PC. And your mouse and your joystick used for playing games. So output peripheral devices are the peripheral devices that displays or gives out the data. So that's why we have your displays or your printers, which are the output that you just maneuvered into the system. So yeah, your input peripherals are the keyboard, mouse, joystick, light pen, touch pen, like I said. And a scanner is also considered an input because you scan a paper, then it scans it into the PC. And a digitizer. Okay, output peripherals. Output peripherals can be classified into two types, hard copy and soft copy. So hard copies, the output produced by this device can be stored, e.g. printers and plotters. So those are the hard copy output devices. And the soft copy are the monitors and that displays like your projector. Sure. So any question, guys, so far? Any question on peripherals, input and output? No questions. Okay, moving on. Hardware inside computer case. So most computer contains the following device inside the case: a motherboard, which contains the CPU, floppy drives, CD-ROM. Okay, can I just do that? Okay, so like your power supply, which we touched on last week's topic, circuit boards and all that stuff. So I'll just move on. So the power supply, we know power supply is the component that supplies power to the motherboard. So reading here, they say a power supply unit converts alternating current, which is AC, to electric power to low voltage, which is DC power. for the internal component of the computer. So it takes the power from the wall socket and it converts it to DC, then supplies it to the motherboard so that all the components that are connected to the motherboard can have power. So the motherboard, we know, is the main component of the computer, which is that rectangular board, which is the circuit or the main socket of the computer. We touched this on last week. So components directly attached to or part of the motherboard, we know it's the CPU. The CPU, you know, is the central processing unit. We saw that last week, which are also the chipset. CPU form factors, we know that we have different types of CPU form factors, which Melusi touched on last week. So I'll be passing on that. Okay, so the random access memory stores the code and data that are being actively accessed by the CPU. So this is the one we touched also about last week, that the RAM is volatile because it stores data that's being maneuvered at that time. So once you turn on the power, it loses that data. So the read-only memory, I just showed you guys that, which is a chipset that has already comes with softwares that are basically installed in. So let's just read on the ROM. They said the ROM stores the BIOS that runs when the computer is powered on or otherwise begins execution. A process known as bootstrapping or booting up. The BIOS, which stands for Basic Input Output System, include boot firmware and power management firmware. Newer motherboards use unified extensible firmware interface. So instead of the BIOS, guys, there's this new system which is called the UEFI. So let me try to see if we can get a BIOS system interface. Okay, guys. So basically, most of the time when you turn on your PC, then you see there it will say, it will start to boot up and write a lot of things, checking all your hardware system. Then if you press like, but it differs in computers depending on the vendor. If you press F1, F2, or delete or escape, basically the computer will enter into a BIOS system, which mostly looks like this. So the BIOS system is the one that lets you, let's see this one. So the BIOS system is the one that lets you set most of your computer configurations, like the date, the time, and the boot sequence of your PCs. So basically, this is how it shows, okay? But then we have the newer one here, like they say, which they say it's the Unified Extensible Firmware Interface. So this one does not show like the BIOS graphic user interface. This one is more user-friendly. So this one will let you see, this is how it displays. So it's different from the BIOS. So basically it's like the graphic user interface. Instead of this one, this olden BIOS, you have this newer one. Okay, so the BIOS mostly is stored on that ROM. There is a chip that stores the BIOS, which is called the ROM. Okay, so every time you boot, your computer boots, it will take the information from that chip, which is the BIOS, the ROM chipset. So different types of RAMs, we know about different types of RAMs, covered that last week. And Mr. Moyo, did we cover there's different types of RAM last week, the SIM and the DIMM?
No, not yet.
We never touched on them, eh? Okay.
Yeah.
Really passed them out.
It
Okay,
was
guys.
only the CPUs and the motherboards, yeah.
Okay, guys, just get a picture of the RAM, just to get you see the types of them. So, guys, yeah, this is the RAM, random access memory. But nowadays they come in different colors. So you see they are green and have this black chipsets. So as you can see, this one is bluish. Okay, so these are the different types of RAM. So coming to the different types of RAM. RAM stands for random access memory. RAM is a place where your computer temporarily stores its operating system, application, program, and current data, so that the computer's processor can reach them quickly and easily. So what the RAM does is what they just explaining here, that every time you're working on data, that data is accessed by the RAM. So it's stored on the RAM. So while by that time you are manipulating that data, it's stored on the RAM. Then every time you close the data, it moves away from the RAM. And also, Mr. Moyo touched on the CPU last week, telling us about the caches and all that stuff, and how they can access memory from the RAM and also for the hard drive to make the processing faster. So the RAM also works on that. That is what the function of the PC working faster. It's the specialty of the RAM. So we have different types of RAM. And again, you must also remember that RAM is volatile, which means it requires a steady flow of electricity to maintain its content, so data stored in RAM stays there only as long as computer is running. So every time the computer is on, the data that will be accessing will be on the RAM. But when you turn on the PC, the RAM loses that data, unlike the ROM. The ROM always has that data. So we have also the SIM, which is single inline memory module, which is different type of RAM. So basically, you can see the SIM also is the same as the one that I showed you, the RAM, and we also have the DIMM. Let me just go into them and explain them before I show you them. So main memory, single inline memory module, and we have the DIMM, which is dual inline memory module, other than RAM technologies. Primary storage or internal memory is computer memory that is accessible to the central processing unit of the computer without the use of computer's I/O channels. Primary storage is used to typically very fast, as in the case of RAM. So we have the SIM. In earlier PC, main memory was stored on the SIM port as single socketed chip, but today RAM is coming. Okay, let me just do that. Okay, let me just start. In earlier PCs, main memory was stored on the system port as single socketed chips, but today RAM is coming in SIM, single inline memory module, or DIMM, which will be inserted directly into the system port. The major difference between the SIM and DIMM: the width of the data path. A SIM has a data path of 32 bits, and a DIMM has a data path of 64 bits. Okay, DIMM technologies. A DIMM or dual inline memory comprises of a series of random access memory integrated circuits. These modules are mounted on the printed circuit board and designed for use of personal computers. DIMMs began to replace SIMs. So we started with SIMs, then went on to later technologies of DIMMs. Buses. So like Melusi talked about, said last week, the bus is mostly like the path that the data takes. So in computer, the front side bus or system bus is a term for the physical bidirectional data bus that carries all electronic signal information between the central processing unit and other devices within the system, such as random access memory, AGP, video cards, PCI expansion cards, hard disk, the memory containing the system BIOS. So the BIOS, you can say, it carries all electronic signal information. So each and every information that moves on the computer, the motherboard, it travels on the buses. So let's try to get a picture of the buses. So yeah, here. As you can see here, mostly on motherboards, we have these lines drawn here on motherboards. Mostly these lines are actually the buses on how data travels and how data travels and where it travels to. Then USB. Nowadays, if you buy a computer, it will come with a universal serial bus connectors on the back. The USB connectors let you attach everything from mice to printers to your computer quickly and easily. The operating system supports USB as well, so the installation of the device drivers is quickly and easy to do. So we have USB ports that we use to connect our USB flash drives and keyboards as an external peripherals. That's what they're explaining there. Then we have the CMOS battery. The CMOS battery is also attached to the motherboard. This battery is the same as the watch battery or battery for a remote to a car central locking system. Most batteries are CR2032, which powers the memory for date and time in the BIOS chip. So the CMOS memory, like we said, like we read here, they say it also stores the date and time in the BIOS chip. So mainly when your PC is giving incorrect date or stuff like that, you know that probably it's your CMOS battery, it's low. So this is how the CMOS looks like, guys. You can see it looks like a battery of the watch. So basically, yeah, this is the CMOS. You find it on the motherboard. So if you remove your CMOS and put it back, you'll find out that your time of your computer will be incorrect, and the computer will require you to input the time and date of the PC because of you removed the CMOS battery. Expansion cards. An expansion card is an expansion card in computing is a printed circuit board that can be inserted into an expansion slot of a computer motherboard or backplane to add functionality to a computer system via the expansion parts. Expansion cards can be used to obtain or expand a feature not offered by the motherboard. So an expansion card, we heard that it is a circuit board that gives more extra functionality to the motherboard. So most of the time, you will find out that let's just look at the expansion cards and expansion slots. Okay, so we have seen that on the motherboard. Basically, we have this looking like things. So guys, these are the expansion slots whereby you put in your expansion cards. So basically, an expansion card gives functionality or extra functionality to the motherboard. So here we can say a motherboard comes up with a VGA, which is something like this. So a VGA, we know it's used to give a display, or it used to connect the display socket, the cable there. So if the one on your motherboard is malfunctioning or it's broken, you can add this one to the motherboard, like we saw on that picture here. You will add this expansion slot here, then it will come up with the extra functionality of the VGA. So some of them differ. Some of them, they come up with USBs. Let's just go to them and see. So some of them, they come up with RJ45, whereby you can connect your network. Some of them, they come in USB to give you extra functionality of USB. Some of them, they used to come up with this coaxial-like input, whereby you use it for also TV. Yeah, so we also have like TV cards, which are like this. Okay, so this is the RAM. So yeah, these are the expansion cards. As you can see, this is how you connect them. So these ones are empty, and this one, as you can see, they inserted it. So memory and storage devices. A memory unit is an essential part of a computer system. A memory unit holds programs and data. It is very important for the computer designer to pay attention to the memory unit design, because the memory system cost is significant fraction of the cost of the total system. The system performance is largely dependent on the organization's storage capacity and speed of the operating of the systems. So that's how important memory is. Storage devices. Computer's data storage, often called storage or memory, refers to a computer component and recording media that retain digital data. So basically, storage is something that stores data. So we know we have different types of hardware that stores data. We have your external drives, internal drives, your USBs, stuff like that that stores data. So going forward, they say data storage is a core function and fundamental component of computers. The price of solid-state drives, which store data or flash memory, has dropped a lot in recent years, making them a better choice than ever to add a computer to make booting up and accessing files faster. So the SSD, guys, which we know is the solid-state drive, is the new hard drive that makes the computer to work faster, unlike the HDD. So basically, even now, but they are still expensive, the SSD. So they are just different in a way that they make a computer fast, and also they don't have a cylinder like that round thing that we used to have in the, what's this, old HDD. So check the old HDD. So you can see, guys, these are for the laptops. This is the old HDD, and this is the new SSD. So this is the old HDD. You see it had that round cylinder thing that rounds. That's why most of the time when your computer has hardware problem with the hard drive, it will start making sound like click, 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 click. That will be the cylinder that rounds. So in the modern SSD, we don't have that rounding thing. So it also cuts the process of making the computer using more functions, so it works faster. Yes, so that's the SDD and HDD. IDE, short for Integrated Drive Electronics. IDE is more commonly known as ATE, Advanced Technology Attachment, and a standard interface for IBM-compatible hard drives. IDE is different from the Small Computer System Interface, which is the SCSI, an enhanced small device interface. Because its controllers are on each drive, meaning the drive can connect directly to the motherboard or controller. IDE and its updated successor, Enhanced IDE, are the most common drive interface found in IBM compatibility computers today. So we have your IDEs, which are the old technology. Let's just check on them. Take this one. So back in the day, we would have stuff like this, which are your IDE connectors, whereby they would connect from your motherboard and stuff. So yeah, they would connect to your hard drive, then you connect them to your motherboard. So this is where you connect them to the motherboard. Basically, in the motherboard, you'd see connectors like this. Those were used for those connectors like this, but they are old now. We don't find them in the modern computers. Yeah, so here they will provide power and all that stuff. Yeah, those are the IDEs. So now we have the SATA, which is Serial Advanced Technology Attachment. SATA is a bus interface for connecting devices such as hard disk drives and optical drives. Serial ATA has designed to replace the older standards. It is able to use the same low-level commands, but Serial ATA host adapters and devices communicate via a high-speed serial cable over two parts of conductors. Okay, guys, can you please give me a few minutes? Okay, thank you for that. So we've seen that SATA replaced the old IDE. So let's go check the SATA. design. So here are the SATA cables, guys. These are the modern cables we use. As you can see here, these ones are used for connecting your hard drives. So instead of this, so instead of using these old cables, guys, we have developed to using these smaller cables, and they are also faster than the old cables, okay? So these ones are the SATA, and these ones are the IDE. These ones were used in old computers. You see, these are the connectors. And on the SATA, these are the connectors, as you can see on the hard drive there. And this is where they go. This is where you connect them. They also used on hard drives and other stuff. Okay, SATA. Okay, RAID. RAID, an acronym for redundant array or independent disk, is a technology that provides increased storage reliability through redundancy. Okay, so guys, this is just to say for storage capability, there's a technology called RAID, whereby we have more capability of storage. Basically, it's like I can say like servers, yeah, something like servers, but it's basically used for storage, having more storage, yeah. So as you can see here, it's just redundancy. So this will be where we store data. A147 doesn't mean nothing for now, but just know that we also have another pool where we store data and another pool where we store data. So RAID is just about data storing. As you can see here, it's a pool of servers. Then as you can see here, this is your hard drive. So all these things that are connected here are hard drives. This is where these are all hard drives. So RAID is all about redundancy of hard drives, having more capability of storage. Hard drive partitioning. You can divide single physical hard drive into more than one logical drive. So hard drive partitioning, basically, it's like when you have a hard drive that has, well, let's say basically 1 tera, you have an internal hard drive that has 1 tera. You can basically partition it into like 3 hard drives, whereby logically it will be like you have 3 hard drives, but you divided your 1 tera into 3 hard drives, whereby you will say on the one hard drive you have maybe 500 gig and on the other 500 gig. And you know that on the first hard drive you store your music or your work stuff, then on the other one you store for entertainment. So that's hard drive partitioning. And another advantage of hard drive partitioning, guys, is that when you're partitioning your drive, you must have a drive that only stores your operating system. So when it crashes, you don't lose your data. That it affects only that hard drive. So any questions so far, guys? Questions? No question, okay.
So just a quick addition on RAID, right? So when it comes to A+, you'll be required to know different types of RAID. We have RAID 0, RAID 1, RAID 5, and RAID there are so many RAIDs, but A+ only focuses on it's only 4 or 3. So RAID is for redundant access, for redundancy, right? For meaning that, let's say, we use it mostly for servers, as he said, right? As Obakeng said, but we can also use RAID to improve the speed of your devices, right? So it was used for that, the speed of the response of the hard drives, and then also for redundancy. For example, RAID 0, what it does is you find that you only need a minimum of 2 hard drives, whereby the other data is stored from one hard drive and the other part is stored on another hard drive. And then we have like maybe RAID 1, which is maybe copies the actual data to another hard drive. So RAID can increase the speed of your system. It was used for increasing the speed of the system. So it depends which type of RAID you go for. They offer different advantages. For example, RAID 0, you find that it offers you more storage and stuff like that. And then you find that the RAID 1, it offers you let's say more disk and more speed, and then more and redundancy again. So that's the most important part when it comes to A+. We need to check out the RAID, the differences of RAID, right? You have RAID 1, RAID 2, different RAIDs. So you have to go through them and check out what are they, and then what are the advantages of all of those RAIDs, right? It's not only for backup, but we use also to increase the speed, and then also for error management, right, on the hard drives. So just check them out, RAID 0, RAID 1, and then is it 6 and 5? Those are the ones that you have to check if you want to take your A+.
Okay, thank you, sir. And I've never went deep into them. Yeah, but I can see that they have a lot of advantages. Okay, moving on from hard drive partitions. Okay, fixed media. Those are your removable media, like I touched on your USBs. To transfer data between computers, a USB flash drive or optical disc may be used. Their usefulness depends on being readable by other systems. The majority of machines have optical disk drive, and virtually all have a USB port. So that's how we get to maneuver data from PC to PC without sharing them on the network. So coming to other types of computers, we have a mainframe computer, which is much larger computer that typically fills a room and may cost many hundreds or thousands of times as much as a personal computer. They are designed to perform large numbers of calculation for governments or large enterprises. So mainframe computers, guys, as we've heard, they are typically big and they are used to do high-end calculations. So basically, we find this in government institution, like they say, whereby we know security has to be tight and sharing of information has to be fast. So basically, this of mainframe computers, as you can see, they are not your typical computers as like your desktop and your laptop. And also we have a supercomputer. A supercomputer is superficially similar to a mainframe, but is instead intended for extremely demanding computational tasks. As of November 2013, the fastest supercomputer in the world is the Tianhe 2 in Gaihanzu, China. So the fastest computer in 2013 was a supercomputer from was this Ganzhou, guys. So basically, supercomputers are also the same as mainframe, as we've heard, but they have faster capabilities than mainframe. So basically, we use them in military operations, whereby military people will have to encrypt their data, will have to share data faster, and also in trading firms, whereby when you trade or you need to take an execution now, they don't have to be any time delay. The action has to be done now. So in those industries, they use supercomputers. System board components used for communication amongst devices. So basically, we touched on this, talking about your peripherals, input and output stuff, and we touched on PCI, which are your expansion slots and other stuff. And last week we also touched on different types of form factors of computers, and also we also have different types of motherboard form factors. So basically, your motherboard will affect the type of form factor case that you have. Functions of BIOS. So basically, we know BIOS is an acronym for Basic Input-Output System, and it is a built-in software that determines what a computer can do without accessing programs from a disk. So BIOS, like I said, it is the first system that takes place when you boot your system. It checks out this input and output devices if they are working correctly. So most of the times when your computer has errors, you'll find out in the BIOS, after the BIOS system boots, it will tell you that we have a memory problem, it will display an error there and say probably error code there or memory something. So we also use BIOS to configure hardwares, the booting system. Like I said, when you have like 3 hard drives in your PC, you can configure which one the PC must boot from. So like last week also, Melusi touched on dual booting, that you can have 2 operating systems in one computer. So basically also BIOS also you can configure which operating system must be the main one. And set the system clock, enable or disable system components. Yeah, those are various functions of the BIOS. Any questions so far? No questions? Okay, moving on. The boot process. The process used to start up a PC each time it's powered on, it's called the boot process. The boot process is performed under the guidance of the BIOS. The BIOS contains the instruction needed to verify, test, and start the PC. The following functions performed during boot process. So these are the steps. The first step is to check whether the initial program load hardware, the minimum hardware that should be working properly. So that's when your PC starts on, the BIOS will check if your all the components inside the motherboard, your RAM, your CPU are working correctly. The next thing is the BIOS next runs the power on self-test routines. The post verifies and tests the hardware configurations stored in the BIOS configuration information. If there is a problem with the hardware, BIOS sounds beep codes to indicate the nature of the problem or displays an error message. So the BIOS, once it finds an error on your hardware that's connected after the post, which is the power on self-test, which does the testing of the hardware if they are all functioning correctly. If it finds any error in those hardware, there will be beeps according to the error that it finds. So most of the time it might be 1 beep, depending on the the error of the functionality of the hardware that's corrupted. So most of the time you'll find out when you turn your PC on, it will start to make sounds like beep, 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 beep. So those 3 beeps might indicate something. So we have a beep code. There's a sheet that gives you all the beeps, that if it's 3 beeps, it's a hard drive. If it's 3 beeps, it's the CPU and all that, depending on the vendor. So after all the successful completion of the test, the bootstrap program is executed. Bootstrap program loads the operating system. Once the operating system is loaded, it takes the complete control of the functioning of the computer system and is now ready to execute user instructions. So before we load the operating system, we know that the BIOS has to take place. Booting is of 3 types: hard boot, cold boot. This boot sequence is taken place when PC is powered on from off position. Within this booting, all of the above sequence steps will take place. Soft boot. This booting takes place when the PC is already powered on and pressing key combination like Ctrl-Alt-Delete or pressing reset button. In this booting, post process does not run. Okay, then we have also a random boot. This type of booting takes place without knowledge of the user. It may take place because of malfunctioning of either hardware or software. Post and important beep codes. The post, which is the power on self-test, which is the one that takes place when the PC turns on, is a collection of test programs. The function of this program is testing the various functional units in the PC and verifying whether they are working or not. The post program are automatically executed whenever the PC is turned on or reset. So that is the post, guys. Every time you turn on your PC, there will be a post that checks the hardware if they are working correctly. Then it will tell you according to the vendor, it will give you beeps to alert you that there's some errors in your hardware. The steps of a post. Each time a computer boots up, the computer must pass the post. Below is the common steps of the post. So the post will do this: test the power supply to ensure that it is turned on and that it releases its reset signal. CPU must exit the reset status mode and thereafter be able to execute instruction. BIOS checksum must be valid, meaning that it must be readable. CMOS checksum must be valid. Then CPU must be able to read all forms of memory such as the memory controller, memory bus, and memory module. The first 64 KB of memory must be operational and have the capability to be read and written to and from, and capability of containing the post code. Input-output bus controller must be accessible. Input-output bus must be able to read from the video subsystem and be able to read all video RAM. So guys, we can check that before our PC turns on, there are a lot of processes that are going through. Hence, when you turn on PC, you'll see that black screen and writing a lot of things. These are the things that are happening behind the scene. No about different connectors. Connectors, normally called input-output connectors, are interfaces or linking devices using cables. They generally have a male and with pins protruding from it. This plug is meant to be inserted into a female part, also called a socket, which include holes for accommodating the pins. However, there are plugs which can act as either male or female plugs and can be inserted into either ones. So those are the different plugs that we have, male and female. So basically, we'd say a male is the one that has a pin inside, and a female is the one that it's also only has a hole. Okay, guys. Yeah. So those are the different plugs that we have. Most motherboards have the following connectors: serial port, which uses a DP9 connector for connecting all the devices; parallel port, which uses a DP25 connector and USB port; and RJ45 connector for connecting the computer into the network; the VGA connector, which is for the monitor. Then we have the jacks, line in, line out, and microphone, which is for the microphone. So let's look into those serial ports. Okay, so. Okay guys, so these are our parallel ports. As you can see, there are different kinds. So this one will be regarded as the female. As you can see, it has holes. Then the one that you connect to, that connects to this one, will be considered the male. As you can see here, the male has pins. So this one is considered the male. Okay, so this one is the DP9. So this is the female and this is the male. Those are the different connectors we have. And the USB port, probably everyone knows it. So these are the different kinds of USB ports that we have. So we have even have different versions of them. So RJ45 connector, which is for the network. So your RJ45 is this one. So this will be the female, and this will be your male. Yeah, this is the female, this is the male. So let's just check the cable, guys. Cable. So mostly this is the network cable. The network cable, their connectors are called RJ45 because of their pin. Okay. Mostly you've seen them around offices with this color, gray. Yeah, these are the RJ45 connectors. We use them to connect for network. And the VGA connector. So yeah, this is the VGA connector, guys. This is the female and this is the male. So this one we use it to connect the display of the PC. This jets. So this one, okay, also this one's are the PS2 for what's this? Your keyboard and mouse. These are the ones. So as you can see, number 6, these two are for the microphone. With other jacks in line for mostly headsets and stuff. Yeah, so for the one for the keyboard is called PS2. Okay, so that will be the end for this one. So Mr. Moyo, I also have the one for troubleshooting.
All right.
Questions?
Troubleshooting. Let's do troubleshooting tomorrow.
Yeah.
Anyone with questions? And then please try to share the document with the guys on the group, right? So that they can also kind of go through it. Yeah, I think it's a very, it was like a very informative class. So I think they will need also to go through it and then, yeah. Nontobeko, what have you learned so far? Asqale ngawo. Nontobeko.
I have a question.
Yes, okay, what's the question?
Yeah,
What?
can you please explain to me the idea of RAID? Because I understand that it's used to increase storage, but how does it really speed things up?
Okay, Melissa will take that.
You mean RAID, how does it speed things up? So we have RAID 1, right? We have RAID 0 and then RAID 1, RAID 5, up to RAID 6. So the delay with most of the hard drives, right? The SGT hard drive is the response time. If you look at the response time of a hard drive, it is measured in revolution per minute, meaning that how fast does it respond to a request coming from maybe a CPU or from any resource from the system requesting anything from the hard drive. So the SGT, the problem is they have that cylinder which is always rotating, of which it is slow. So if you have one drive which is maybe, let's say, most of them, their speed is it 75,000 revolutions per minute? Some of them is 15,000 revolutions per minute. Some is 10,000 revolutions per minute, right? So if I'm using only one, right, so that means the system's only going to wait for that specific one hard drive. But now when I have like two of them, all of them supporting the hard drive, all of them supporting the CPU, it becomes easier and faster for them to respond to the request that can be done, requested by the CPU, unlike when you're using one. So we normally say, okay, there are some RAID types that don't really help when it comes to speeding up things, right? So there are some types of RAID. I'll check for you which RAID really does help when it comes to response time. So for example, some they are solely based on the redundancy, the backup part. If one hard drive fails, you have your data on the other side. And then there are some that really are designed for upping the speed of your PC or upping the speed, the response time of your hard drives. So I'll check for you which one specifically does that. But the number of RAID or the number of hard drives that you have on your system, all of them working to respond at the same time. Unlike when you have like two hard drives that are not configured as RAID. So there's this thing, right? Sometimes you might have two hard drives in your machine, but they're not configured as a RAID system. What does that mean? It means that you only have one hard drive that responds to the request from the CPU, and then the other hard drive, what it does is it's just a storage device. So that's the difference. RAID, what it does, it creates a platform whereby all of the two hard drives or all of the three, all of the hard drives that we have, they all respond. That's so that the CPU or the PC on its own, it uses those hard drives, those 5 hard drives or 10 hard drives, as if it's one hard drive. So that's different from using, let's say, 2 hard drives, saying, okay, now So it's different from saying, okay, I have 2 hard drives in my PC, right? That's not RAID, like just having 2 hard drives in a PC, and then the other one is used as for booting up, and then the other one is used as for storing data. That is not RAID. RAID, it creates, like there is another hard drive. There's a software for RAID. There's also like a hardware that you can use for creating RAID, right? So there are 2 types, software RAID, and then there's a hardware RAID. And then they always say the best one will be, is it the hardware type of RAID, right, that you use. So that system, what it does is it makes sure that when your CPU interacts with the hard drive, it interacts with all of the 5 or 10 hard drives that you are using as if it's one hard drive. So the response time now, it increases, unlike when you're only having 1 hard drive. So that's the thing when increasing the speed of the RAID. So you can see there we have increased data security, fault tolerance, data parity, increased read-write speed. So this is the part that I'm talking about, the read-write speed, right? So the other hard drive might be reading information, and then the other one is writing information. So now the speed or the response time from the hard drive, it gets increased from the system. So the important part that you need to know is that you having 2 hard drives on a machine, while you didn't like really configure RAID, is different from when someone is using a software for RAID or a hardware for implementing RAID. So that's the two different things. So the software is kind of like slower than the hardware type of RAID. So those are the advantages that are on the screen there for RAID, right? Data reliability, increased read-write speed, right? The response time of the hard drives. Data parity is whereby some of the information is stored on different hard drives, and then when you want to rebuild that information from the hard drive, you can pick it up because it was doing what we call the parity, like if let's say you lose 1 hard drive, so meaning that the entire data from your system, it doesn't disappear. You can still have access to that information because there was data parity. So you can rebuild the information. So you have to check out which specific RAID does all of these things, right? Some the increased data security, some fault tolerance, which is if the 1 hard drive fails, then and then you have another hard drive that is can work for you. So okay, I think with RAID 0, if I'm not mistaken, RAID 0 uses a minimum of 2 hard drives. So what it does is some of the information is stored on let's say some of the pieces of the information stores on hard drive 1, and then some of the pieces on hard drive 2, right? So if hard drive 2 fails, it means that now you have lost some of the information. You can't rebuild that information. So RAID 0, what it does is it provides you with what you call speed, increases like the speed of the hard drive, something like that. And then RAID number 1, I think, is the one whereby the exact same of data that you have on hard drive number 1, you have it on number 2. So what RAID 1 provides is data redundancy, right? Meaning that, okay, if I lose hard drive number 1, the same copy of information is on hard drive number 2. So those are the things that you have to look out. Just like dive deep into the different types of RAID and then check out, okay, which one provides what. So if you're looking for increase in speed, you note, okay, maybe you go for a RAID 0. If you're looking for maybe for backup, like data redundancy, fault tolerance, you have to check maybe it's RAID 5 and RAID 4. So those are things that you have to check out. So I think, does it like answer your question? I don't know who asked the question.
Yeah, no, you did actually answer my question.
Yeah, so
yeah, you did, and you actually made ask another one right now.
Yeah.
Now, are there really specific computers where we can apply RAID in, or is it can be on desktop, supercomputer, mainframe, or?
Mainly, this works fine if you are on the server side, right? Most people that implement RAID on the servers.
No.
So you find them mostly in the data center, yeah.
No, okay. Now, but I'll do some more research. But thank you very much then.
Yeah, so and then the other important thing is people always confuse this RAID with maybe like, let's say you're having 2 hard drives on your machine, and then they say, okay, I have implemented RAID, of which the other one is just a storage, and then the operating system or your PC deals with the first hard drive. So RAID, there would be like, most of them, there will be like a software, if you want to implement the software part, and then there'll be another one whereby it is the hardware that controls those hard drives. So they usually say the hardware ones are the ones that are really quite faster when it comes to RAID. All right, any questions? Any questions? All right, so let me just quickly, yeah,
Are the SATA's cables used according to their colors or size?
The SATA cables. Well, basically the SATA cables are the same. All of them, they are the same. So they come in different colors, but the function is the same. You might have the red ones and some of them are blue. So the functionality is all the same.
All right. On this part of the RAID, right? Check out, we have the RAID. Is it the 6-pin one? This small one. So the 6-pin one, it only transfers data, right? So the 6-pin is for data, and then the other one for 15. The 15-pin is for power. So check out the smaller one. Yeah, just that one. Yeah, just click on that one. That's the one for this one. This I think, if I'm not mistaken. And then A+. The other thing about A+, they require you to know the number of pins on these. So they'll just say a SATA 6-pin. I think it's 6-pin if I'm not mistaken. So this one transfers data, right? It's only solely deals with data from. Let's say you want to transfer data from the hard drive, maybe going to the motherboard, then to the CPU. This one transfers data. And then where's the 15 one? Check out the 15 one.
Probably this one.
So this is, I'm sure, if I'm not mistaken, it's been a while without doing A+, right? Okay, it's a 15-pin. All right. So this is the 15-pin. This one is the one that transfers power from your, let's say, coming from the motherboard and then powering your hard drive or your optic disk drive, or most of those devices that connect using the SATA drive. So just know that for A+, you need to know, okay, the 15-pin, it transfers power, right? It's for power. And then the 6-pin is for data. Can you click on this on the 6-pin again? I just want to see the one. Just go back to the 6-pin. Over again. Just click on the 6-pin again. I just want to see something. Can you guys hear me?
Yes, sir.
Okay, hear you, but it seems Overking is not there, man.
Overking maybe. All right. So I just wanted to be sure that is the really a 6-pin. So when you're writing your when writing your A+, right, that they need you to know. Okay. Okay. Now I was presenting using Overking screen. Now everything is gone. All right. So basically, the 15-pin, right? You need to know what the 15-pin is used for, right? We said the 15-pin mainly is for, we say it is for power, right? And then the 6-pin, but check it again if it's really 6-pin, because I'm not sure, 6 or 8-pin, but if I'm, yeah, 6, somewhere there. And then we have, okay, let me go through my slides. I might have these somewhere on my slides. Come on, check it on the slides. Let me just check if I have them here. Okay, these are the cooling systems, the RAM, DDR2, memory. No, I don't have. Okay, we're gonna get to the part where we talk about those. Okay, let me also maybe try this. SATA connectors. Man. Okay, let me check if I can have let me see. Okay, guys, can you see my screen, right?
Yes.
Yes, I can see.
All right, let me see. I was sure that I wasn't 100%. It's a 7-pin, not a 6-pin. Is it what? Yeah, it's a 7-pin pin data receptacle. All right. So it's for data, this one, right? So if you're doing A+, just you need to know that this one is for data, and then the other one will be for. Let's see. Where is the other one? So this is the one. So that one is 7-pin. So you need to know the number of pins. We said the other one is 7-pin, and then this one is 15-pin. So this one is for 10. And then this connection that we have here on the side, the white one that we have on the white side, and then we have the black one, which is the 15, and then we have the white one, which is your we call the molex, right? 4-pin females, the molex. So okay, we're gonna get to that part. Let me switch to my slides. Come on. Let's see, is this the other one? Oop. All right, so basically what we're doing now, you guys, can you see the CompTIA career pathway, right?
Yes.
All right, so basically what we're doing here is we're trying by all means to prepare you guys, especially the ones that want to take the international exams. The thing is with most companies, organizations, when they're hiring people with, let's say they're hiring you for a job, for a tech support job, they require you to have maybe, let's say your system support level 4, 5, or your system support level 5, your tech support level 4, and then they also require you, if you go now maybe to LinkedIn or to any job site, right? They're asking you for these two, right? For minimum entry, right? Your A+, your network plus. So that's why we are going through these so that you can understand. Oh, if you really want to take the exam, after this, you can be able to go and then take your exam, and then becomes easy for you to pass the exam, right? So that's why we're going through this. So here is let's say there's some people that might be interested in infrastructure, so you can go through these career pathways. Most people these days, they prefer, okay, the most paying one these days is the cybersecurity, right? So you can pursue the cybersecurity career and then get these, or you can do the infrastructure pathway, which is the Linux Server Plus and then the cloud. But most people these days, they're taking the route of the cyber security pathway, right? So these are the options that we have. Once you get your NQF level 5 system support, then you can pursue these. Or right now, as we are going through these, you can prepare yourself for the A+, the network plus. I know we have IT fundamentals, but most companies, they don't ask you for your IT fundamentals plus. These are the two that they ask you for, the A+ and then the network plus. So that's why we are kind of basically going through these. So when we're going through the networking, we're covering what we have on the network plus, and then when going through the hardware and the software part, we're covering what we have on the A+, so that if you are really interested in IT, then you can pursue this. I know that in this learnership, there's some people that are not really interested in IT. They just wanna or they want the stipend and stuff like that. But these classes are for preparing the people that really want to pursue IT as a career. That's why I always say, if you have any questions, if you have any topic that you want us to talk about, just send me a message, and then we are going to cover that so that it can be helpful when you are in the work environment or you're applying for a job. All right, Stack Up certificate. I'm not interested in that right now. Where am I going now? What am I looking for? Come on. So this is the A+ slide, right? So A+, preparing you for comparing operating systems, right? So the ones that you guys that are under Retro, I forgot the name of your company, but it's Retro, right? So the company that you are in. So now we are doing module. Is it module 4? What module are we doing this week?
Module 4.
Module 4. So you'll see that when you're going through module 4, there is a part where it talks about the multi-user operating systems, right? And then we have the end user operating system. So we just want to go through that now. And then also this information that we're going to cover now, we just want to go through this for 30 minutes, right? Because we're only left with 30 minutes. Our class is usually is supposed to be 2 hours, right? So I want to go through this. It will help you also to be able to complete your module 4, and then also if you want to take your A+, then it covers the same thing. All right, so compare and contrast common operating system types and their purposes. So we have that the 32-bit versus the 64-bit. What is the difference between a 32-bit operating system and a 64-bit operating system? Is there any difference between these?
I can say it's the file allocation table, whereby the 64-bit has more memory than the 32.
Right, so if you have a 32-bit operating system, the number of RAM that it can understand or it can read on its machine is limited to 4. Is it 4 gig or 2 gig of RAM? Ah, shucks, it's been a minute. So 32-bit is limited to a certain number of RAM, right? So in a work environment, a 32-bit operating system, we don't use a 32-bit operating system. So we always go for a 64-bit because it allows us, we have no limits when it comes to the amount of RAM that we can install on that machine. You can install up to about 192 gig of memory. You can install more than that on a 64-bit. So the 64-bit and the 32-bit, it just says, okay, this is what I can handle, right? The instruction set that I can handle on my site is this much. So the 64-bit and the 32-bit is just the difference. And then the other thing is that you have to look out for, let's say your operating system is a 32-bit operating system, right? And then you're going to be limited in terms of like softwares that you install on that machine. For example, if your operating system is 32-bit and then you download a software which is 64-bit, and then you try to install that software on your machine that is 32-bit, and then your software is 64-bit, then the system will tell you that it cannot read or it can't you can't install that type of software because of the instruction set. Right, the number of instructions that a 32-bit can handle, and then the number of instructions the 64-bit can handle. It says, okay, this is more than what I can handle. So a 32-bit operating system only runs applications that are 32-bit. So when it comes to a 64-bit operating system, or a 64-bit CPU, it can run any application that is a 32-bit. So if your operating system is a 64-bit operating system, then any application that is 32-bit, it can run it. And then it doesn't have that limit. I think the limit for 32-bit gig of RAM is, I think it's 4 gig if I'm not mistaken. It can't go higher than that, but you check that one out again. You need to know this for your A+, right? And then software compatibility, this is the part that I just explained to you now. Okay, a 32-bit operating system cannot run any software that is a 64-bit because of the instruction set, but a 64-bit will always run those 32-bit operating system, what you call softwares on that machine. So these are the things that you have to look out for in a work environment, in any organization. The software, the operating systems that we're going to run on our machines is going to be the preferred ones, is going to be the 64-bit because of the amount of RAM that it can handle, it can understand, and then also the software limitations or the RAM limitations or compatibility, right? And then a workstation operating system, Microsoft Windows. So we have different types of operating system. Obakeng went through these, like the types of operating systems that we have. He said we have like the ones under Windows, Windows 7, Windows 8, Windows 10, and then we had now they're introducing, is it Windows 11? I saw people having conversation about Windows. Was it Windows 11 that they're working on, something like that?
Yes.
So Windows have a lot of those operating system, and then most of the people they are using, most of the organizations are using Windows systems as their end user operating systems, right? So these are dominant in most of the organizations, right? And then it's not only Windows, also we have the Mac OS, we have like the Mac iOS, we have like the what you call the Linux. Linux is a big family. We have CentOS, we have Ubuntu, we have Red Hat, we have it's a big family, right? So those are different operating systems, and then you need to know the different types of operating systems. So we have operating systems that are used by the end user, and then on the material that you guys are using for system support level 5, it's the servers, something called the servers, right? And then on that material, those servers, they call them the multi-user, right? So those, they call them the multi-user operating systems. So the multi-user operating systems, these are the servers that serve like the end user or the workstations that we have in our work environment. For example, we have a server that we can call it a file server, a print server, what you call a web server, any type of a server. So the client on our computers, we spoke about these, the terms, the language that you're going to hear being used in a work environment, whereby people call a computer a workstation, they call your laptop an end device or a client. So those devices, we call them a client, and then we call a server the one where everything is central, where everything is in, where some people, they call it a multi-user operating system, because everyone in our organization, any user in our organization, when they request or require any resources in our organization, they communicate directly with the server, and the server, we have configured maybe, let's say, permissions on the server grants permission to that specific user. So most people, most computers, most clients in our organization will be communicating directly with the server. So a multi-user operating system is a system or an operating system that services a number of people or a number of end users in our organization. Right? Sometimes a multi-user operating system, you find that there are so many people that can be working on that device at the same time in that specific machine, right? So we have those servers that we have in our organizations. All right, and then we have what we call the vendor-specific limitations. So there's a different, when it comes to specs, I think I will, vendor-specific limitations. So when it comes to this operating system, what happens is when you are downloading, let's say you downloaded Microsoft Windows 7, right? And then they will tell you the limitations of that system. For example, the minimum requirements of RAM, the minimum requirement of the CPU. They will tell you, okay, this system or this operating system can only run on this minimum of RAM, and then this minimum of the CPU, and this minimum of storage device. So the vendor specific, they will have like the different vendors will tell you, okay, what is their limitations when it comes to minimum requirements, hard drive, RAM, CPU. And then end of life, this is the term that is used when, let's say, Microsoft, it doesn't support Windows 7 anymore. We call it, we say that the operating system, you have come to an end of life, meaning that the vendor or the owner of that operating system, they no longer release new patches, they no longer release any support for that specific operating system. For example, now Windows 7 has ended, is now become end of life, has reached end of life, right? Microsoft doesn't support Windows 7 anymore. I was looking at downloading Flash Player, and then I just found out now that Flash Player is no longer supported by Adobe, right? They stopped supporting it last year, something like that. So you can download it, you can find it somewhere else, but once an operating system becomes, when they say it's end of life, it means that it's no longer safe to use, right? Because the owner doesn't release any patches anymore, so it might have many vulnerabilities on that specific system. So end of life, it just means that the manufacturer, the vendor, the owner of the system no longer support that, meaning, okay, they're done. They're saying, okay, I don't need this anymore. So if you use it, you're using it at your own risk. So in an organization, right, we have policies that we have in place whereby the organization or the chief technology officer, the chief information officer, they will tell you, okay, these types of software in an organization, we cannot install it, right? Because of the known vulnerabilities on that system. And then sometimes some will tell you, okay, if software is end of life, reach end of life, it means that, okay, our company, we don't need that particular software in our organization, right? And then, all right, update limitations. These are, okay, once it's end of life, like there are no updates coming out from the manufacturer or the vendor. All right, and then the other one will be compatibility concerns between operating systems, right? Compatibility. So the other one, like maybe they can't run or they can't communicate with each other, stuff like that. Those are the compatibility concerns between operating systems. All right. Compare and contrast features of Microsoft Windows versions, right? So Microsoft is what we call editions. We have like the versions, right? So now we're looking at the version Windows 7, we have Windows 8, we have Windows 8.1, we have Windows 10, right? So A+ require you to know the features that you find on all of these, even though Windows 7 has been phased out, but they need you to know the features of these, right? So we have the versions, right? And then also we have the editions, right? When we're breaking down the editions, we find that Windows 7 has Home Edition, has Pro Edition, has Enterprise Edition. And then all of those editions, they come with certain features, right? For example, the Home Edition, you find that the Home Edition, it was designed for home use. Like, let's say that's an operating system that is designed for home use. So the features that comes in with that specific operating system, if it's a Home Edition, it means that it is designed to cater for people that are working, let's say that it's not for work stuff, it's only for home use. So the features that you're going to find there maybe is for the player, the music player, the video players. So you don't find things like domain, whereby you add people to a domain. So those features are not there on the home editions. But you find maybe the domains mostly on the Pro Edition, on the Enterprise Edition, because in an organization, you're going to be using the Pro, the Enterprise, we also get Ultimate, right? So those are editions. So this operating system, they come in with what we call the version. So when they talk about the version, you find people are saying, okay, Windows 7, Windows 8, Windows 8.1, and Windows 10. And then they break it down again into editions. Right? Editions are broken down into, let's say, Windows 7 Home Edition, Windows 7 Basic, Windows 7 Ultimate, Windows 7 Pro, Windows 7 Enterprise. So those are editions. Again, after editions, we are saying all of those editions, they have their own features that come in with that specific edition, depending on the use, what is it really used for, right? Okay, so corporate versus personal needs. This is the part that I was talking about. Domain access. A personal needs. We don't need a domain access for personal use or someone who's sitting at home, right? So they don't need domain access. Domain access is whereby it provides us with capabilities of adding people into a domain. Domain, what it does is give us like a central control of our network. For example, we can create usernames and password and then give it to different people. If computers are in a domain, you find that, okay, the username and password that I give to you, you might use that same username and password to log in any computer that we have in our organization, because all of my computers are part of a domain. So your username is not checked locally on your machine. If you type in your username and password, it's not checked locally on that machine. What it does is it takes that username and password and then checks it on the server and then try to find out, okay, does this person exist on our domain name, on our domain server, right? So on our domain, when I add everyone on the domain, then you can use the username and password to log in on every machine that we have in the organization. That's the use of a domain access. So you can see that type of capability or that type of feature, we don't really need it on a personal computer, because the personal computer or the computer that you use at home, it is used maybe by 2 people or 1 person at home, right? So they just need a local username and password, right? Just to log in that machine. So only 1 account can be created for that. Okay. And then we have the BitLocker. The BitLocker is a security feature that allows us to lock our hard drive. So it encrypts our hard drive. For example, if you have activated BitLocker on your machine, if someone steals your computer or maybe they steal your hard drive, now they will need the password in order for them to decrypt the information that's on the BitLocker, on that information, or what you call on that hard drive. So sometimes it restricts them from uninstalling or installing any operating system on that specific hard drive. If you ever find like a hard drive sometimes that you try to install a new operating system, but it always asks you for a username and password. Anyone who have seen that? For people that usually install operating system, have you ever seen that, like where you try to install a new operating system on a hard drive and then it restricts you from doing that? Asks you for username and password.
Yeah, I've seen something like that. I've seen something like that.
So that most of them, it will be because of the BitLocker. In order for you maybe to decrypt that, usually you have to take that hard drive and put it on the same laptop that it was on, and then try to come out to guess the password that the person used in order for you to be able to access the information that is on that machine. So that's another feature that really comes in handy when it comes to corporate information, corporate data, right? So we always try by all means to protect the information that we have in our corporate environment, right? And then the media center, mainly the media center is a good platform for for personal needs, right? It caters for personal needs. If you want a media center, you find that you have like videos, we have video players, we have photos and all those things. It's a good tool for people at home. And then the branch cache is for network or data optimization. Like for example, people that are working from home and then connecting to a WAN or connecting to any. So it kind of like it's a data optimization tool for people that are working from home or trying to access the organizational resources. So it's a network optimization tool. And then we have the EFS, like encryption file system. This one, it encrypts files. It doesn't encrypt the entire hard drive. So the difference between the BitLocker and then the EFS is just that it encrypts, EFS encrypts the file, right? The entire file. If there's a folder that you want to encrypt in your machine, then you can use the EFS to encrypt that. So you are specifically encrypting one specific folder in your machine. And then when you're using BitLocker, we are encrypting the entire hard drive. That's the difference between these two, right? And then when it comes to the desktop styles and user interfaces, so all of these, Windows 7 and then Windows 8, if you look at the Windows 7, that the interface is what the user interacts with, what you see when you are using your Windows 7. So Windows 7, if you look at the user interface, we have the start button, which is quite different from the Windows 8. So when we came from Windows 7 to Windows 8, most people were like, okay, this is quite different. Most organizations, they didn't really like Windows 8. So Microsoft had to quickly introduce Windows 10 to cover up for the mess up, as I can say, the mess up that they did with the Windows 8, because most people didn't like Windows 8. They were like, okay, no, it's kind of difficult to use. And then there were some other issues and people were like, okay, they were reluctant to move from Windows 7 to Windows 8. As you all know that when a new version comes in, most organizations, we have to move from the current version and then move to a newer version that we are using, right? So on this part, most organizations, we were reluctant in terms of like moving to Windows 8 because it was quite complex, like kind of difficult for people to understand because we're used to Windows 7. For me, I really liked Windows 7. I use Windows 7 now also on my home desktop where I have my games on it because it doesn't really chow a lot of my RAM because it has fewer processes that are running on the background, unlike Windows 10, which has like more processes that are running, of which it takes much of your RAM. Right. So back in the day, if you look at the computers that were maybe 2 gig of RAM, when you're running Windows 7 on a 2 gig of RAM, it never used to give us any problems, never used to slow down. But right now, if you install a Windows 10 on a 2 gig of RAM PC, then you will see that the PC, it starts slowing down, start facing problems with RAM or system trying to process things because Windows 10, it has like maybe 300 something processes that are running on the background. Can someone check for me online how many processes Windows 10 has and then how many processes Windows 7 has? Okay, check for me. Just check online for me that part, right? The processes that Windows 7 have running on the background and the processes that Windows 10 have running on the background, right? I just want to get that information. I forgot that info. All right, and then desktop styles, user interface, we're saying you will see these are quite a bit different, right? Okay, any questions before I move to the next slide? Kopile? Any questions?
I have a question regarding the previous slide.
All right, let me just go big. Yeah.
Yeah. With the 32-bit versus 64-bit. So you said that a 64-bit operating system can write a 32-bit software, right?
Yeah.
And then you said that 32-bit softwares or 32-bit usually has some restrictions on the amount of RAM that can be used.
Yeah.
Now, does that mean if I have a 64-bit operating system, maybe 8 gig RAM, and I run a 32-bit software, only 4 gig will be used, or will the whole 8 gig or whatever will be used?
No, all the 8 gig that is going to be used. So as long the thing is, as long your operating system is a 64-bit and then you download a software which is 32-bit, then all of the RAM, entire RAM will be used because it's sitting on the 64-bit, which is the operating system, and then 32-bit is just the software. So the 64-bit will address all of the RAM that you have on your machine, even though your software is 32-bit. But the most important thing is that your operating system has to be the 64-bit.
All right, thanks, man.
So make sure that organizations, we only go for the 64-bit. if you're in a work environment, even like these days, if you are like, I don't advise people, I don't think like most Microsoft Windows, let's say Windows, I don't think they still produce manufactured operating system that is 32-bit because of those limitations, right? Like, I'm not sure if they still release that. Just check it out if they still release if there's any new 32-bit operating systems, because most companies like we don't go for 32-bit unless if it's for home use, because most people, they don't even know what a 32-bit is, a 64-bit is. Sure, Lechabo?
Yes, just check the Windows 7 is running up to 63 processes, and then Windows 10 is more than 200.
So you see, this is the part now that slows down the operate or the system, your entire system. For example, if you go to a task manager and try to check, okay, how much RAM is those processes are taking from your machine, you'll find that maybe the 2 gig is already gone from your machine, used by the operating system on its own. And then now when you open Chrome is another biggest animal that chows your RAM, right? So when you open Chrome and then plus your Windows 10, you find that a 2 gig RAM, and now the entire system starts scrolling without even you opening other documents and other stuff, right? Because of that. But when we're using Windows 7, the processes now, like we didn't have problems like this. So now Windows 10, I think these processes, they are the ones that are really kind of like slowing down your system. And then most organization, when it comes to the web browser, right, the browser that we prefer is the Firefox, right? You see that most companies, if you go to them, the only browser that they use is Firefox. They don't use Chrome. They don't use Internet Explorer. Okay, Internet Explorer, like nobody likes it, but now they introduced the latest one, which kind of like is quite different from the older one, right? From the Internet Explorer. What do they call the newer one? It's Edge, right? So they released Microsoft Edge. So Edge is quite better than the Internet Explorer. But for me, the browsers that I go for is either Chrome or Firefox. But most organizations, they'll tell you, okay, they only install Firefox just because of maybe security reasons, or maybe for that issue of like people complaining about storage or RAM or system being slowed down by these processes. All right.
Boy, the Safari is still running, man.
Say that.
Is Safari still existent? It's like, what's going on?
I think so. I think it's still there. Yeah. But I haven't used it in a while. So yeah, not sure. But I think they still do support it.
I think they reached a dead end.
Or they reached a dead end.
Yeah.
End of life.
End of life, I mean to say.
Yeah, so these are the problems that we're going to face when working on these systems, right? So you just need to, in order for you to be a good technician or a good system support, you need to fully understand how the systems work. I always tell people that there is no way you can troubleshoot a system that you don't even know how it works, right? So first you have to break down the system, and then find out, okay, how does this system works, right? And then you know, okay, RAM works like that, it's used for this and that, and then maybe operating system, these are the different types of operating systems that we have, and then that system works like this and that. And then now, once you fully understand how a systems work, you'll be able to pick up with, okay, this problem is caused by 1, 2, 3, because you know the role of each and every component that's inside the computer. Unlike when you don't know the roles of all of those, it becomes difficult for you to pick up and say, okay, the problem is caused by 1, 2, 3. Right. So first, that's what we're going through now. We're going to get to a part whereby we're going to be sending questions about troubleshooting, right? So now what we're doing is trying to make sure that you fully understand these components, and then after that, you will be able to troubleshoot and say, okay, if the system is doing like this, I know this component is the one that is responsible for temporary storage. So if it is not responding, the system will behave like this, and then you know, okay, easily pick up the problem and then fix it. All right, so A+, let me move to, given a scenario, use Microsoft operating system features and tools, system utilities, Notepad, Explorer, MS Info 32. Have you guys used Microsoft Information 32? MS Info 32. No, anyone have used MS Info 32? No one. Okay, so these are the tools that you need to know in order for you to be able to, or to be good in troubleshooting, right? So these are the tools that will make things easy for you. We're going to go through these tools, all of them, right? Explorer, we know what Explorer is, we know what a notepad is, and then view hidden files. Okay, the folder options, this is another important part, right? So the users are going to come to you a lot with this information, right? They're saying, okay, someone else, we once had a problem and solved a problem whereby someone wanted to go do some presentation, right? And then yesterday, the day before, they were working on a document that the presentation slides, and then they loaded that information on their desktop, on their machine, right? And then, but now when came a time for them to present, that file was nowhere to be found, right? So now with folder options, this is the part whereby you can find all of the hidden files, all of the files that maybe are swallowed by the virus or something, or hidden extensions or general options. This is the part now you're going to be able to pick up the file, find the files that are missing or hidden. So we're going to get into this part and then also move to the power options and then try to find out, okay, how do we go about, and then what do these part mean, and then how do we solve problems that are related to this. Okay, let me try to go to MS Info 32 quickly. So you just go to search, right? Or you go to run MS Info 32. So let me see if I can, I don't want to switch my screen. Okay, I'll come back to this because now, okay, let me do this. Can you guys see my system information? No. You still see the slides?
Yeah, only the slides.
Yes. Okay, I just wanted to share it. Okay, but on your computer, if you're using any computer, right, go to run or to search. Especially run will do good for you, right? Type in MS Info 32. It will give you Microsoft information about your systems, right? Like that's the shortcut if you want to find out information about your system. And then there are other options again. What you call that one? Let me check it again. Okay, we're gonna go through these ones. I don't know when. So because they are important for you to troubleshoot. I'll pick up all of them and then we'll go through them together. So that one will be like the practical, because now I'm just going through theory, explaining you everything to you. I don't know if it's tomorrow's coming in, Solom's web development. Okay, we're going to find a day whereby we go through the practical of this, looking at the tools that are the inbuilt tools, utilities that Obakeng spoke about, the tools that we can use to monitor our system or to troubleshoot our systems, right? Okay. All right, comparing operating system. Okay, there's another information that I want to give the guys that are doing the multi, are going to be doing module 4 this week. Let me see if I'll be able to get. Okay, now comparing operating system conceptual, right? Personal computer operating system versus server OS. The amount of memory that you find in a personal computer, you find most people, they prefer the 4 gig, the 8 gig, the 6 gig of RAM, right? For them, it's fine like that, right? They prefer, it's okay. The 4 gig, the 8 gig of RAM, for them, it works fine. But on a server side, we need the most of the powerful, the server must have like the highest specs. Because remember, it is not only for one user, it is for many users in our organization that will be interacting or communicating directly with the server. So it must be a system that can really quickly respond to the requests that are sent by the users from our organization. So the amount of memory in the server must be way higher than what we have on the like your normal PC or your operating system or your personal computer, right? Number of processors, last time we spoke about the quad core, the multi-core, all of those things. So when it comes to server side, we need to have like the highest performing processors, right? Because this is the server. Again, it's different from the personal computer. On our personal computer, we can use our what do you call our Core i7, whatever we call. So now when on the server side, you find that we have things like the operating system or the processors called the Ryzen that are used maybe on the server side. AMD, they have their own. So check out the processors that are used on the server side, right? So it must be a powerful processor, because remember the server, it is used by many people that communicate directly with the server. It's not for a single person. Okay, number of concurrent network connections. You find that most of the times your server has maybe 2 or 3 network connections or network interface card at the back. So that it can be fast, or it can for redundancy or for fault tolerance, things like that. And then application support, operating systems, multi-user, they support more. They have like many applications that we can install on the server operating system, and then some of them are controlled. We can't install everything on the server side, right? There's like a limited number of applications that we can install there, right? And then must be the ones that really serve like a number of people in the organization. Okay, pre-configured priority level for process services. Pre-configured priority. Priority is just like the what level do we have in terms of like are you in as an administrator? Are you in as a guest? Are you in as a we have guest, we have admin. What else do we have? The levels that we have on an operating system. We have the guest, we have the admin. What's the third one? We used to have like the super user. We used to have, what's the other ones? Okay, you're gonna the other operating system that we're going to dive into is Linux, right? The basics of Linux. We'll go through the basic of Linux and then see what we can do with Linux, right? Okay, pre-configured security. So on the Microsoft, on Windows, let's say on the multi-user of Windows operating systems, the Windows Server 2016, 2002, 2008, all of those, they have like the pre-configured security. For example, one of the pre-configured security is the use of passwords. For example, they will specify that your password, you can only use it for a month. And then after that, after a month, and then you need to renew that password. So it's pre-configured on the servers. And then the other thing is, let's say you need to change maybe your password maybe after 3 months, right? So the first one will be to change your password after 3 months, or maybe to like there are certain pre-configured security. Okay, the second one will be the strength of your password, right? How strong your password is. They will be so strict in terms of like they will tell you, okay, what characters you have to put in there in order for your password to be accepted on a server. So when you're using your personal computer, all of those security measures, they are not implemented on a personal computer. You can type in your name, let's say maybe Melusi123 on a personal computer, that can be accepted. But on a multi-user operating system, they will specify and tell you, okay, only these, they will say, okay, these are the accepted characters for you to create a password. And then after a certain number of time, days, a month, you have to change your password for things like that. So those are the pre-configured security measures in your system. And then support for high availability, which is the number of people requesting services from the user, from the server. So it has to be quickly to respond to all of the requests coming from the users. Services supported, Microsoft, they support their servers. So you have to call them and then they support it. Also with personal computer, you find the updates online, you find the what you call the word fixes. So they do the updates. And then licensing, this is whereby you need to have a product key. I'm sure most of you have heard about the product key, or sometimes you find that, okay, if you don't have the product key, your system will tell you, okay, sorry, you can't use this because there's no product key. Or there are some of the functions that are deactivated because there's no product key. So we have what we call the, for organizations, we usually buy maybe one product key or one license for all of our devices for all of our systems that we have in our organization. So we go to Microsoft and then we say we need like an organization license or product key that will cater for that will be used for all of the systems that we have in our organization. So it might be one. And then you find, okay, that maybe your personal computer, one product key, it works for that one specific operating system, and then you can't use it on a different machine. Unlike what we have in an organization whereby one product key can be used on different machines, right? So that's licensing, you have to pay for that, the cost, the support options that comes with it. That's it there. So we have looked at this, the domain access, the corporate, the BitLocker, the media center, the EFS. What else do we have? The versions. These are the versions 7, 8, 8.1. And then these are the editions that I was talking about. We said we have the home editions, home premium, ultimate, professional, enterprise. And then when you're writing A+, you need to know these, right? That home is used for what? What are the features that you find on a home edition? What are the features you find on professional? What are the features that you find on enterprise? Sure, simply.
So I've noticed regarding licensing.
Yeah.
Would it be bad to actually not spend at all? Because I've seen other people who use other activators to activate windows and offices instead of buying the product keys. Now, is that really bad?
When you're at home, right, everyone does that. For me, I've never bought any product key. Like I use the correct one, right? Like the ones that you find online, you download them and then you just like type in it there, right? But when it comes to organization, we are audited, right? So we have
Hold on.
organization that audit that are we using that the correct tools. So they might just show up in your organization and then ask for licenses that you have for your Microsoft systems or for your Cisco systems. So we get audited always. So if you are caught using the wrong product keys, the ones that you just got online, then your organization, they will have to pay a fine or they will be charged. There will be a lawsuit that comes with that. So when I'm at home, I'm not home users. We are not worried about auditing, right? Nobody comes to your home and says, "Okay, do you have a license for your Microsoft for your Windows 7, for your Windows 10, right?" But organization, we get audited all of the times, most of the time. So we need to get to buy these licenses so that when they come in, the auditors, we can say, "Okay, yes, we bought this license from Microsoft, and then all of the tools that we're using, we have the license for." Does that make sense? Does that answer your question? Zimbili, can you hear me? All right, can you guys hear me? Something happened to me.
Yeah, I can hear you.
You can hear me. All right. I'm not sure if Zimbili got that one. Okay. What enterprise, professional, ultimate, home premium. Okay, so these are different editions that you have. So you can see now Windows 8, okay, it's past 2. All right. So guys, tomorrow we have another class, right? So we're gonna continue from where we left off. Obakeng is going to go through his material. I'm not sure if it's tomorrow, but we're gonna talk with Obakeng, and then we're gonna send out a message to you guys telling you, okay, what are we doing tomorrow? Is it Cisco? Is it web development? Or we are continuing from this where we left off today? So we're going to communicate with you guys. All right, guys. Any questions? Kiriboni?
Sir, can we have the slides when we are done?
All right, I'll share the slides with you guys.
Sure.
Okay. Kiriboni, can you hear me? Mobile. Chisetso.
Yes,
Yeah,
I can
Kiriboni,
hear you.
you can hear me. Yeah,
Yes,
just a quick one, right? We're just doing a recap, right? In summary, what have you learned so far? Kiriboni, let's start with you. Then we move to Mobile. Kiriboni, your mic is off.
Okay, I've learned about the peripherals and the operating systems, which is okay, I wrote them here. Okay, I've learned about the output devices, which are the visual display units. And I've learned about the input devices, which are the input devices, the output devices, and the storage devices in a computer.
Okay. Thank you. Mobile. Mobile. Mobile Prudence. All right, Chisetso, on your side, what have you learned so far?
I've learned the BIOS system, the SATA's cables, and the RAID. Yeah.
All right. Spuda, you have been quiet. Spusis, talk to me. All right, guys, just drop in your names before you leave the meeting, right? Just type in your names there, and then you can leave the meeting. Thank you, guys. See you tomorrow online.
Cheers.